Hey there, educators, and welcome back to the Make Math Happen podcast. I'm Laneshia, and today we're digging into the activate portion of your lesson. This is that crucial stretch of time that really sets the tone for everything that follows. So, this is where clarity, consistency, and connection collide. I'm going to break down what the activate sounds like. I want to model it in action with a real classroom problem, and then I want us to connect it to the ELEOT high expectations component. And I really want us to zoom in on how learners demonstrate and describe high quality work. By the end of today's episode, I want you to have a vision for how this moment in the lesson isn't just warm up time, it's where rigor and readiness begin. So we're going to start by framing the activate. Let's defining it a little bit. The activate portion of your lesson is more than just a bell ringer. It's a deliberate setup that invites students to connect prior learning, anticipate what's coming next, and engage in reasoning right away. My district defines this as the first 5 to 10% of the instructional block where teachers are guiding students in unpacking the performance-based learning objectives. So I want to zoom in just a little bit about what that 5 to 10% of your class looks like. Okay. I have broken this down into 5 components. Now you hear that, you may be thinking, that sounds like a lot, but I want you to bear with me because these are 5 things that you're probably naturally doing some combination of. I just want us to be a little bit more strategic with these components. Okay. So the first thing is the bell ringer. So again, this is the time where we might be spiraling back to prior skills or previewing what's coming in today's lesson. It is available upon entry, so students can immediately start. And this shouldn't take more than a few minutes to complete. Okay. So it's just enough time to get your attendance done or any other administrative tasks that you need to take care of. And students are immediately engaged. After the bell ringer, we need to synthesize. So this is where you're going to tie things together. You're going to highlight any patterns or connections because hopefully there are some for today's lesson. And we need students to see those connections. So number 1 is the bell ringer. Number 2 is the synthesis of that bell ringer. Number 3, we have to review the learning objectives. So we need to highlight that I can statement and let's annotate it. Okay, let's look for those key terms. Are there any visuals that make sense? Models that are going to live in some type of visible spot. Now, I know many of us use our slide decks to host our I can statements, but I'm going to challenge you to put those I can statements on your whiteboard somewhere where it is going to be visible throughout your lesson so that students can look there and reflect. Am I on track to meeting this goal? Like kids need to know that this is the goal. This is what we're moving towards. So by them seeing it, by it being visible, they can check in with themselves throughout the lesson. And the onus isn't just on you. It's on everybody in that room, right? Number 4, the launch of the initial task. So students are moving into their first high cognitive demand task of the day, and it should be done with clear and concise directives. So this doesn't mean you're telling them how to do the task, but it does mean that students know what they're about to do, the amount of time they're going to have, and they should be engaging in some type of routine that makes that task accessible. Examples of that are 3 reads, and it could also be like a notice and wonder, right? So we want to provide a low floor for students so they can just step right on into the task, but then also have that high ceiling so that there are plenty of levels that they can work towards. Also, we have to synthesize this initial task as well. Before transitioning to the instruct part of your lesson or the meat of your lesson, we need to anchor what was discovered in the bell ringer and that warm up. Okay. What was discovered? What do we need to clarify? I want you to think about this part of your lesson like a warm up for both the mind. We're warming that mind up. You just got into class, and I want you to be quickly acclimated to what's going to take place in here today. And it's also a warm up for the mission. Okay. So we're setting the conditions for productive struggle. Students need to understand that everything is not going to feel easy. And people have different definitions of easy. There's going to be time where you're going to feel a little bit of frustration. Okay. Now, not a lot of frustration to the point that you're pulling out your hair or beating on the desk or anything like that, but you're trying to figure something out. And sometimes we might need to just sit back in some quiet time and make sense of what we have so that we can get to the finish line. And students need to understand that that's a part of learning. That is a part of shifting that long-term memory. I want to model this for you. I want you to hear what it sounds like. All right. So when students have come into my classroom, remember that bell ringer was already waiting for them, and it was an intentional bell ringer. It was something that was going to pull in a fifth grade concept. So in fifth grade, they were dividing whole numbers by fractions and fractions by whole numbers. So I'm going to kickstart them with this lesson where we're going to be dividing fractions. I want to pull in something that they've experienced, right? I want to give them some encouragement. I want to draw them in and make them feel like I have something that I can contribute. Okay. So as students are finishing their work and we're getting close to that timer going off, I am already preparing what student strategies I am going to share because I'm going to be synthesizing when that timer goes off. And I want students to start to see those connections because this is going to set the tone for everything that's going to follow. It's going to help them when we move into our first task. I'm getting ready to go into teacher mode. All right, we ready? Action. I noticed a few different strategies as you guys worked this morning. One of you guys used a tape diagram to model how many lawnmowers could be filled if the company has 4 gallons of gas and each mower uses 1/3 of a gallon. Another one of you guys wrote a division expression. You wrote 4 divided by 1/3, but you weren't quite sure where to go next. And then a third student said, I wonder what I can multiply 1/3 by to get 4. And that was a very interesting pathway. So I'm writing all of your strategies on the board because I want us to be able to reflect back to these different strategies as we move through the lesson. So our goal for today, let's read it together, guys. I can divide fractions with the same denominator with and without models in order to solve problems. Well, what does it mean to divide? It means to split into groups or to share equally. Okay. So we're splitting an amount into equal parts or groups. Okay. So what are denominators? They're the bottom number. The bottom number? Is that the only way we can describe it? Okay, so let's clarify that just a little bit. The denominator gives the fraction its name. It tells us how many pieces make up one whole. For example, in 4/5, the whole is divided into 5 equal parts, and 4 of those parts are shaded. So, who's ever eaten sushi before? Okay, what's your favorite kind of sushi? Okay, my favorite kind is the cooked kind. So I guess I'm really not a true sushi eater, but I dibble and dabble. Okay? All right, so today's situation, I'm going to read it first, and then I have a question for you. Jason is making sushi rolls. He has 5/6 cups of rice and will use 2/6 of a cup for each roll. How many whole sushi rolls can Jason make? What is this situation about? Yes, it's about making sushi rolls. Good job, Johnny. Rebecca, can you read it a second time for me? Jason is making sushi rolls. He has 5/6 of a cup of rice and will use 2/6 of a cup for each roll. How many whole sushi rolls can Jason make? Thank you. What's countable or measurable in this problem? How much rice he has. Okay. How much rice he needs to make a roll. Okay. Is there anything else that's countable or measurable? The number of rolls he can make. Okay. So now what I want you guys to do is I want you to take 1 minute to read it silently. And I want you to think about what strategy could you use to figure out how many whole sushi rolls Jason can make. When the minute is up, I ask students to share their initial thoughts. I jot down their responses. One student shared that they can draw a model. Another student shared we can break down 5/6. Another student shared we can just divide. So after capturing those students' ideas, I'm going to give them about 5 minutes to work independently. I am going to circulate, I'm going to take notes, and I'm going to look for representations that will move the discussion forward. When it's time to wrap, I'm going to synthesize strategically. I'm going to highlight 3 approaches sequenced by complexity. So the first one that I'm going to highlight is decomposition. I'm looking for a student who broke down 5/6 as 2/6 plus 2/6 plus 1/6, okay? And from that, they were able to determine that they could make 2 full rows or 2 whole rows and that there was a little bit of rice left over, okay? I'm going to show that strategy first. In the second strategy, it's going to be a tape diagram. So I had a student draw the tape diagram similar to what they did in the bell ringer, where they started off with 5/6 shaded, and then they highlighted or circled groups of 2/6 to show the same reasoning as the decomposition strategy, but they just showed it visually. The next strategy that I'm going to highlight is a student divided 5 by 2. They just wrote 5/6 divided by 2/6. They remembered that that denominator is just the fraction's name. So I can just look at the numerators, look at those parts, and divide them to figure out how many whole sushi rolls he can make. After I've gone over those strategies, after I've made note of those strategies, I'm going to let those strategies kind of live on my whiteboard. I need them to stay up there so that students can refer back to them. And after I've done that, after I've made some connections, asked them questions about how one strategy links to the other, I've got another question for them. So, what was our goal for today? To divide fractions with and without models? Exactly. And every one of these strategies helps us do just that. NC. So what I wanted to do is after we've synthesized and connected those strategies, I wanted to bring their attention right back to the goal, okay? And it's on the board. I'm affirming the fact that they know what the goal is, and I'm telling them that's what we're going to use today, okay? So that's what a strong activate sounds like. It's a deliberate synthesis. It's a connection to prior learning. It's an authentic launch into today's thinking. So now let's connect this to what we should see and hear during an ELEOT learning walk. So if you have administration coming into your classroom and they're using the ELEOT learning walk tool, this is for you. There is a component up there called high expectations. And the indicator that I want us to zoom in on is the learners demonstrate and are able to describe high quality work. So this does not happen by chance. Okay. It's intentional. All those students are brilliant and they have so many awesome ways to show their thinking. Does it reflect high quality work? That is the question that we want to ask ourselves. Here's how we build their pathway to demonstrating and describing high quality work. We need to first create the exemplar as a teacher. So before students ever begin the task, we need to identify what does proficiency look like. And it's not just the correct answer. It's not just Johnny got the answer right, but the reasoning, the structure, the clarity that represent the quality. So what is it that they're thinking about? How did they structure this? Do they know what these fractions look like? Is there clarity in what they have created on their paper that gives me the evidence I need to say, you know what? Johnny's ready. Johnny's got it. Johnny is to the point where I could have him teach a peer. After we create the exemplar, we need to make it visible. Let's post it, project it alongside the success criteria with language like, I can divide fractions using models or not using models, right? So I want to show that exemplar and I want to put it right beside that I can statement so that they know that there is a link there. So think back to my model. There were students that I intentionally selected to share, and then I did put them in an order. I put their strategies on the board. I was personally putting their strategies on the board. I did that for a reason. I know we like to have students come to the board, and I respect that. However, sometimes it takes a lot of time when we are bringing students to the board, right? And also, their images or their pictures sometimes might not be as clear for everybody to understand. So I'm still going to give Johnny, Rebecca, and Robert the credit for the strategy. I'm going to put their name up there. I'm going to make them feel real good, but I may be the one that actually draws it or creates it, or I may have already created it in my slide deck because I expected someone to do it. And then it's already up there, ready to go. It's neat. I can keep rolling, right? So these are the exemplars. And I also want to have those exemplars next to that I can statement so that students can say, if I am rating myself on whether or not I can do this thing, I should be able to do what is listed next to it. This is what high quality work looks like. Okay. So those are my exemplars. That's what I planned for. Now students can reflect back to those models if they get stuck as well. So not only are they rating themselves, but if I have a student that's stuck, now he knows, okay, this is the goal and this is kind of how I get to the goal. And remember those strategies that I shared, they were kind of scaffolded. Did you guys pick up on that? One of them was doing repeated addition. One person drew it. One person started something but didn't quite finish. But then when we got to the warm-up part, there was a finish. So the students are able to see it and they can connect to whichever one most correlates to the level that they're on right now. Okay. So then on our pathway to building students' ability to demonstrate and describe, we need to compare and reflect. So as students share, we need to invite them to self-assess. How does my work compare to the exemplar? Where am I meeting expectations and where can I grow? So some students may be like, I might need to grow in creating the model because I don't know how to draw the model. Oh, no problem. I'm going to give you gritted paper so you don't even have to think too much about it. There's always the squares there that you can use. Another student may say, I can grow with setting up the division expression because sometimes I don't know what to put first. What's the dividend versus the divisor? Oh, got it. As we're doing our 3 reads like I did today, my follow-up question is going to be, what are we dividing? And then what is the size of the group or what is the number of groups? I need to talk to them about that language so that they know this is what should be going through their head as they're figuring out how to set this up. So while students are working on the next task, they can easily check in with themselves about their progress towards the goal. And when we are making thinking visible in this way, it makes it easier for us to see if the evidence is there or not. It makes it easier for us to support students because now they can say, okay, this is where I need the help. A lot of times we're asking kids, well, ask me a question or what don't you understand? They don't know what they don't understand. I don't know yet, ma'am. I don't know yet. Okay. So this is going to help them figure that out. So when people are coming into your classrooms, things that they're looking for as evidence of high expectations for this demonstrating and describing is students referencing posted criteria or exemplars, conversations grounded in reasoning and precision, students who can articulate the why their work is high quality, not because it's neat, okay? That's not it, but because it is mathematically sound, okay? So when you think about your Activate, don't underestimate the power that you have in that first 5 to 10% of your instructional block. This is where you're going to be planting the seeds of clarity, of rigor, and of confidence. So I want you to ask yourself, did my bell ringer meaningfully connect to today's work? Did I model what high quality thinking sounds like? Did students have a chance to talk, reason, and connect ideas before I jumped into teaching? That's how we move from an activity to activation. In the next episode, we're going to continue this thread by unpacking pre-teaching, how to anticipate barriers and build bridges before students even arrive at the task. Trust me, you won't want to miss it. Until then, keep making math happen, one intentional move at a time.